I'd like to start by differentiating my substitution, but at the moment I've got u squared as a subject, which I don't particularly like. I could square root both sides like this. Then I could differentiate u with respect to x, but I don't like doing that with the square root because it means that I get negative fractional powers and then gets quite messy to rearrange. Instead, if I add 2 to both sides, then I've got x as a nice simple function of u, which is much nicer to differentiate. There's no square root, so there's no negative powers or anything like that. Much neater, much tidier. So differentiating x with respect to u, the u squared will just differentiate to be 2u. The 2 will differentiate to be 0. And now we'll make the dx the subject. So I can replace this dx here with a 2u du. Let's leave the x squared and the square root of x minus 2 for now. We'll change those to be in the u world in a minute. So all I've done so far is changed the dx to be 2u du. Right, so let's look at the other parts of this integral now then. So we've got the x squared on the top. I know that x is u squared plus 2, so I'm going to put that there. Right, now let's look at this denominator. What's this in the u world? Well, if I were to take here and square root both sides, I'd find that u would be equal to the square root of x minus 2, which is what I've got here. So this is just u. Which is then quite nice because I've got a u here and a u here, so they're going to cancel out. Right, so after all of that work, what are we left with? We've got the integral of u squared plus 2 squared multiplied by the 2 with respect to u. Right, let's expand these brackets out. So the u squared will be u to the power 4. Then I've got 4 lots of u squared plus 4. But all of that needs to be multiplied by this 2 here. So 2 of those. We'll have 8 of those. And we'll have the 8 on the end. Each of these terms will integrate reasonably nicely now, so we're going to add 1 to the power and divide by the new power. Add 1 to the power, and divide by the new power, and the 8 will integrate to be 8u. And now we just need to make sure we go back into the u world. Let's remember that we've already said, so I go back into the x world, we've already said that u is equal to the square root of x minus 2, so I can swap this to be the square root of x minus 2, and this and this. I could leave my answer like that, but I do know that this square root here means power of 1/2, which will tidy up quite nicely with the powers of 5 and 3 there. So if I swap that to be a power of 1/2, then the 1/2 times the 5 will be 5/2. Similarly with this next term, that will be 3/2. And the last term, well, we'll just write that as a power of 1/2, just to be consistent with the others. And I mustn't forget my plus c. And we're done.